The number of electrons in the outermost L shell of an atom is 5. What is its electronic configuration? So we have K, L, and in the L they said there are 5 electrons. So I put 5 here. So K must have been 2. So the number of electrons will be 2 plus 5, 7. And the configuration will be 2, 5. The next they are asking us what is the valency of it. So for valency we have to write the configuration again. It's 2 and 5. So 5 valence electrons. 5 valence electrons. 5 valence electrons means unstable. It has to have 8 valence electrons. So to gain stability you need 3 more. So it has to gain 3 electrons. 5 plus 3 becomes 8. So valency equal to 3. So the reason for this, the atom will gain 3 electrons to attain octet state. And hence, therefore, valency is 3. Write the number of protons, neutrons of an element whose atomic mass is 27. Atomic mass equal to 27. Now, an atomic number is 13. So, atomic number equal to 13. Now you remember that atomic number is protons. Protons is 13 and mass is protons plus neutrons. So neutrons and protons is 27. We know the protons is 13, so I'm going to put 13 here, plus neutrons is 27. So neutrons is 27 minus 13. So here neutrons will be now 14. So the question is find the number of protons. So we know protons equal to 13 and neutrons equal to 14. The other part of the sum says write its valency. Now to find the valency we first have to do electronic configuration. So atomic number here is 13. So configuration will be 2, 8, 3. If you see in valence electrons are 3. So valence electrons 3 unstable. So what it will do, it will lose the 3 electrons. Therefore it will lose 3 electrons to become stable. So valency will be 3. Next is identify the compound. To identify the compound, all we need to know is atomic number. Here atomic number we know is 13, and for atomic number 13 is aluminium. Aluminium has atomic number 13, so the element is aluminium. For the element, find its valency and give reason for the valency. We have 6 and 3. Now here we know that 6 is mass number and 3 is atomic number. Atomic number is 3 means protons equal to 3. If protons are 3, electrons also 3. Now let's go ahead and write its configuration. Here configuration will be 2, 1. Valence electrons, these are the steps you need to use to find valency. Valence electrons 1, outer electrons 1, so it's not stable. It will lose 1 electron, and hence valency is 1. Now let's just summarize this valency thing. So we have to find valence electrons. To find valency, you must know valence electrons. If valence electron is 1, it will lose 1. Hence valency will be 1. If valence electrons 2, the atom will lose 2 electrons, valency 2. If valence electrons 3, it will lose 3, and hence valency 3. If valence electrons 4, it will share 4, valency 4. Now if valence electrons are 5, it will gain 3. Let me write it in another number, another color. So valence electrons 5, it will gain 3. Because 5 plus 3 becomes 8. So valency is 3. Valence electrons is 6. Remember, it has to become octet state. It needs 2 more. It will gain 2. Hence valency 2. And 7, it will gain 1. Hence valency 1. And if it is 8, it does not gain nor lose. So valency is 0. So all these gain electrons. And because they gain electrons, they form negative anions, and they are non-metals. The ones at the top here, all these, they lose electrons. And because they lose electrons, they are all metals. They form positive ions. Magnesium 2412 and magnesium 2612 are symbols of 2 isotopes of magnesium. Compare the atoms of these isotopes. So we'll just find out all the subatomic particles. So we have magnesium 24 and 12. We'll take this up first. We know the mass number is 24, and we know atomic number is 12. So, and then the next step, we know mass. We'll calculate the number of neutrons. So atomic number is 12, means protons equal to 12. Now they said mass number is 24. So first remember, protons is already we've calculated 12, mass is 24, mass is protons plus neutrons. So that would be 24, protons is 12, neutrons 24, and the neutrons also become 12. So when we get to magnesium, we have protons are 12, electrons are 12, and neutrons are also 12. So this was about the subatomic particles. I will check the electronic configuration. Electronic configuration, electrons are 12, so it will be 2, 8, 2. Now valency, 2 valence electrons, so it will lose the 2 valence electrons, so valency will be 2. Let's go up to the next isotope, magnesium 12, 26. So we have atomic number, which is number of protons is 12. We have mass number 26, and you know mass is protons plus neutrons is 26. The atomic number protons was 12 plus neutrons 26. So neutrons 26 minus 12. So neutrons will now be 14. So we saw protons was 12 because atomic number was 12, neutrons is 14, and electrons will also be 12 because protons equal to electrons. Now for the electronic configuration. So for the configuration of this atom, we see the atomic number is 12, so the configuration will be 2, 8, 2, valence electrons 2, so not stable, hence it will lose 2 electrons, and the valency will be 2. Now we know in the nucleus of this atom you have protons plus neutrons. So there are 12 protons and 14 neutrons. So they'll have 26 nucleons in this atom. Now let us compare these two atoms. Atomic number 12 and 12. So we have atomic number 12 for both. Then when we come to mass, this is 24, and here I have 26. So mass 24, here mass 26. Now number of protons is atomic number, so 12 and 12. So electrons also will be 12 and 12, protons equal to electrons. Now for neutrons, to find neutrons, we do 24 minus 12, so in this case it will be 12, and here 26 minus 12, here the neutrons will be 14. Now for configuration, electrons are 12, so configuration 2, 8, 2. Here configuration also will be 2, 8, 2 because they have here 12 electrons and here also 12 electrons. So valence electron is outermost electrons, this valence electrons. Here is the valence electron, so 2 in both the cases, so valence electrons 2. So valency also will be 2. And the nuclear composition is protons plus neutrons. Here also protons plus neutrons. Protons plus neutrons. So 12 plus 12, 24. And here also protons plus neutrons. And that is 12 plus 14, and that is 26 will be the nuclear composition. 12 protons and 12 neutrons. In the next case, 12 protons and 14 neutrons. Which of the following are isotopes and which are isobars? Let's examine the first A and B. Here we see that the mass is the same. Mass number same. However, atomic numbers are different. Here atomic number is 28, here 26. Atomic number different. When mass is same and atomic number is different, they are isobars. And the next one, have you seen, this is same, the atomic number is same. But look at the mass is different. So we have atomic, we have mass, number is different. And this is the definition of isotopes. So X and, oh this is Y, this should be written as Y here. X and Y are, isotopes are X and Y, and isobars are A and B. A has atomic number 238, so I'll write A here. Atomic number 238 and mass number 238, atomic number 92. And B has mass 235 and atomic number 92. How many protons and neutrons do each have? So let's get on with the calculation. So we have atomic number equal to 92, means protons equal to 92, and the mass is 238. So protons plus neutrons 238, but we know the protons are 92, so 92 plus equal to 238, so neutrons equal to is 146. So we saw that the protons is 92, neutrons 146. So let's write that. Protons 92, neutrons 146. Now for the next one, atomic number equal to 92, and atomic number we know is protons 92, and mass number is 235. Mass is protons plus neutrons 235. We know protons is 92, 235, so neutrons 235 minus 92. So neutrons here is 143. So for this atom, protons 92, but neutrons 143. Now, are A and B isotopes of the same element? Comment on their properties. Now here we see that the atomic number is same. They have same atomic number. And because they have same atomic number, they'll have same electronic configuration. If they have same electronic configuration, they'll have same chemical properties and same chemical properties. Such atoms are called isotopes. In fact, these are isotopes of uranium. An element has mass 31 and atomic number 15. So let's start on. They will write with the atomic number first. Atomic number is 15, means protons equal to 15. In the next step they said mass is mass number equal to 31. So protons plus neutrons is 31. Now we know that protons is 15 plus neutrons 31. So neutrons 31 minus 15. So neutrons will be 16. So number of neutrons is 16. Then they said find the number of electrons in the outermost shell. So we need to write its configuration. To know its configuration, first we must know atomic number. Remember, atomic number is very important. It's more important than the mass number. Atomic number is 15. So configuration is a distribution of electrons 285. So how many electrons in the outermost? 5. They are called the valence electrons. Valence electrons equal to 5. Give one important application of isotope of cobalt, and we already have seen it is used in the treatment of cancer. Elements A to E, the number of protons and neutrons are given. Elements from A to E, the number of the protons, electrons and neutrons are given. First we have to find a cation. So for a cation is positively charged, which means the protons must be more than the electrons. So in which of the cases are the protons more than the electrons? And if you see here for B, the protons are 9 and electrons are 8. So protons are greater than the electrons, so B is a cation. Next we have to check an anion. Anion is negatively charged, which means the electrons will be more than the protons. So in which of the samples are the electrons more than the protons? If you notice, it's here, electrons 4, protons 3. So we have here electrons 4, protons 3. So electrons more than protons, therefore we have A is an anion. It must be negatively charged. Next, pair of isotopes. Isotopes are the ones that have same number of protons. So if you look here, 17, 17. D and E have the same number of protons. So for D and for E, for both of them, the protons are 17, same, so they are isotopes. We have to find an atom of a noble gas, outermost orbit stable. So look at C. C, 18 electrons. So 18 electrons means configuration 288. Outermost is 8 valence electrons. Filled orbit. Orbit is absolutely filled. So it is stable. It must be a noble gas. Write the 3 isotopes of hydrogen. So hydrogen has got 3 isotopes. Now remember, they are isotopes, so their mass and the atomic number will be same. The mass will be different. One has got 1 mass, here 2 and 3. And they have a name. This H11 is called protium. Then this is deuterium. And here is tritium. These are the isotopes of hydrogen. State one use of isotope of uranium. Now uranium isotopes we have already studied. It is used as a fuel in nuclear reactor. Next, isotopes have similar properties. Now why do isotopes have similar properties? Is because first, isotopes have same atomic number, and because they have same atomic number, they have same electronic configuration. And since they have same electronic configuration, they have same chemical properties. Atoms that have got same valence electrons have similar chemical properties. The average atomic mass of a sampling element is 35.5. What are its percentage isotopes? Percentage of the isotopes. So we have 2 isotopes here. One is Y, 37 and 17. So we'll say let the percentage be X. And we have another one that is Y, 35, 17. And here, therefore, the percentage will be 100 minus X. Let me explain this. 100 is the total percentage. If one element is X, other one has to be 100 minus X. We use the formula X percent of Y, 37, plus 100 minus X percent of Y, 35, equal to 35.5. So X percent of 37 plus 100 minus X percent of 35 equal to 35.5. We take the LCM, so 37X plus 35 into 100 minus x over 100 equal to 35.5. 37x plus, when you open the bracket, you get 3500 minus 100x is minus 35x equal to 35.5 into 100. We open the bracket.
The second one was,
this is minus 35x, open the bracket, 3500. So 37x minus 35x will be equal to 350. So 2x, and this would be minus 3500. So 2x equal to 50. So x equal to 50 over 2, x equal to 25. So the first sample, that was y 37, will be 25%, and the other sample, that was y 35, was 100 minus x, that is 100 minus 25, it will be 75%.